So welcome to my YouTube channel. So today we are going to talk about circular motion. Okay, circular motion. So what is this circular motion? Okay, so you can see this word has two parts. Okay, so it has the first part which is circular and the second part which is motion. Okay, so circular means just a circle. Okay, and motion is just movement or moving. Okay, so that's what it means. So circular motion is just when an object, you have an object here, moves in a circle at a fixed point. Okay, so this is what we call um circular motion. When an object moves in a circle at a fixed point, that's what we call circular motion. Okay, so now I'm going to run you back to the basics of forces and velocity. So if you have like an object, the force is acting parallel to the velocity. What do you think will happen? Will the object speed up or slow down? So when the force is acting parallel to the velocity, the velocity of an object will speed up. Okay, speed up, speed up, right? Speed up. Okay. So what happens? What happens if the force is anti-parallel to the velocity? So if the force is acting in the opposite direction to the velocity, so what do you think will happen? So the object will slow down. Okay, slow down. If the force is acting in the opposite direction to the velocity, the object will slow down. Okay, so that's I'm just trying to introduce something here. Okay, so what if the force is perpendicular to the velocity? Okay, the force is perpendicular to the velocity. What do you think will happen? Okay, so if the force is perpendicular to the velocity, uh, uh the object will move in a circle. Okay, it will bend. Okay, so object object moves in a circle. It's because the force and the velocity are perpendicular to each other, which will make an object move in a circular motion, in a circular path. Okay, when the force and the velocity are perpendicular, an object moves in a circular path. Okay, so now let's put this concept which you have learned into a real life example. Okay, let me delete this. Okay, deleted. So imagine you have a lock. Okay, you have a rope. So this is you standing here, and you have a lock. You have a stone here, and you have tied the rope. So let me put the rope in red color. Okay, okay. So this is your lock. You have put it in here. Okay, and this rope is moving on a circular motion. Okay, it's moving in a circular path. Okay, so the center is this part. This is the center, and the distance from the center to the rope, it is the radius. Okay, so the force acts at the force acts at the center. Okay, so the force is from here up to here, so it acts in the direction of the radius, but the velocity of the stone acts in a straight line. Okay, it acts in the perpendicular to the force. Okay, let me remember them. Which color will I use? Okay, so this is the force and the velocity. So as you see, the force and the velocity are perpendicular to each other. So this will cause the stone to move in a circular motion, okay? As we learned earlier, that if the force and the velocity are perpendicular, it will cause an object to turn. Okay? It will cause an object to turn, okay? So just carry this concept as we go through this chapter, okay? So let me delete this. So we are back with our example, okay? So I have a question for you. Why doesn't the stone fly away? Okay, fly in this direction. Why does it keep it move? Why does it keep moving in a circular motion? Okay, so objects want to move naturally. Objects want to move in a straight line according to Newton's first law of motion. As it says, an object continues in their uh, uh, straight line of motion according to Newton's first law. Okay, continue moving in a straight line and unless compelled by an external force to change their path of motion. Okay, but in circular motion, something must constantly pull the object toward the center. Okay, something must pull the object toward toward the center. So that is the force is the one which pulls pulls the stone toward the center, and this force is called the centripetal force. Let me write it properly. So the centripetal force is the one which pulls the object towards the center so that it may not fly away. Okay. So the centripetal force. Okay. Centripetal force is the one which pulls the object toward the center, and it makes a 90 degrees with the velocity so that it causes the object to move in a circular motion. Okay, that's why. Okay, that's why an object doesn't fly off, because there's something pulling it toward the center. So the centripetal force is also called uh the center seeking force. Okay, seeking force, center seeking force is also known as the centripetal force because it pulls object toward the center. Okay, so now we are going to look at the key quantities in circular motion. Okay, so let me wrap this part. So I'll wrap this part. Okay, so let me write it in the key quantities in circular motion. Okay, so what are the key quantities in circular motion? So the key quantities which are measured in circular motion, the first one is the displacement. Okay, so the displacement. What is the displacement? What is this displacement? So displacement is just the change in position. Okay, that is displacement. The change in uh the change in position. So it is displacement. Okay, when you move from one point to another, that is displacement. You have moved from one part to another, and displacement is a vector quantity. It has both magnitude and direction. Okay, so I'm going to use a blue color, and the second one is the distance. So the distance. Okay, what is this distance they're talking about? So how far along the circle you have traveled? So it's the distance you've traveled along the circle. Okay, the how far you have traveled along the circle, because we are dealing with circular motion. How far you you have traveled along the circle. Okay, so and the third one is um, angular displacement. So angular displacement. So what is this angular displacement? Okay, so the angular, let me write angular displacement, and it is represented by something like theta. Okay, it's written like theta, but it's not theta. Okay, so the angular displacement, this is the angle you've turned, measured in, and it is measured in radians or degrees. Okay, so I've said the angle you have turned. This is the angle you have turned. Is the angle you have turned. Okay, and it is measured in radians or degrees. Okay, it is measured in and one revolution. And what are these radians? Okay, first of all, so one revolution is equals to 360 degrees. So one full cycle is equals to 360 degrees, and in radians we can represent it by 2 pi radians. Okay, so 360 is equals to 2 pi radians. Okay, yeah, remember that. So the fourth quantity which we're going to look at is angular velocity. Angular velocity. Okay, and it is represented. Let me write it properly. So angular velocity, it is represented by W. Okay, so what is angular velocity? Okay, so angular velocity it's just how fast the angle changes. Okay, it is just how fast the angle changes. Fast the angle changes. When you're moving from one point to another, the angles will be different. So angular velocity measures the angle changes. Okay, and the formula which we are going to be using is W is equals to change in the angular displacement over change in the time. Okay, and the units are radians per second. Okay, so you have to get this formula, write it down as we come up in this section. Okay, so and the fifth thing which we're going to talk about, that is the time period. Okay, so what is the time period? The time period is the time taken to complete one full revolution. One full revolution. Okay, so to put it graphically, so the time period, you have this circle. So the time it will take, let me represent it by the book. So this is the object. So the time it will take from the object to move from this part to again this part, this is what we call the time period. Okay, and it is represented by um, letter T. Okay, so letter T. Okay, that's what it is represented by after letter T. Okay, and yeah, the sixth thing which we're going to talk about, it is the frequency. So the frequency. Okay, so what is this frequency? So what is this frequency? Okay, so frequency is the number of revolutions per second. Okay, so frequency is the number of revolutions per second per second. So that is frequency. Oh, one thing which I forgot about, it is the formula for the period. So the formula for the period is 2 pi the radian over the angular velocity. That is how you uh, define the period in circular motion. Okay, and the frequency is the number of revolutions per second. So the number of revolutions per second is what is represented by the frequency. So the formula for the frequency is 1 over t. Okay, that is the frequency. So if you want to it is just the opposite of period. So you can represent it by angular velocity over 2 pi. Okay, so um so in this video uh, we are going to be using the radians because it is most preferred when dealing with circular motion. So a full circle a full circle equals to 2 pi radians. Okay, and a half circle is equals to pi radians. Okay, so you have to remember that, it's very important. So now we proceed. Okay, so now we're going to connect the arc length and the angle. Okay, so this is a circle, right? We're going to connect the arc length and the angle. Okay, so this is you and the radius is this. Okay, so suppose you move at an arc length of L. Okay, so you are here. Okay, so what is the range between um so this is the angle theta. Okay, so what is the relationship between the arc length and the angle? So the arc length, which we are going to represent by L or S, so we are just going to be using S. Okay, so S is the arc length, is directly proportional to the radius. So the radius is this part, and the angle. So if you increase the angle, the arc length will also increase. So they are directly proportional to each other. Okay, so remember this formula also. Okay, so we have this simple problem just to make use of the formula which I presented earlier. So the question goes like this: suppose you walk halfway around the circular track of radius 10 meters. Calculate angular displacement in radians. Okay, so we are going to use our formula, which is angular displacement is equals to radius times um uh, the angular. Okay, so this is our formula, right? So going to 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 the Prague values have been given. So our radius is 10 meters, and our angle needs to be in radians. So uh, the key part of this question is halfway. So halfway means half of the circle, and half of the circle we said that it is pi, right? If we remember in our previous discussion. So we are going to put, so our r is 10 times our radian is in pi. So as we know, pi is approximately 3.142. So 10 times 3.142 is 31.42 meters. So that is our angular displacement.